OpenAI put an AI agent system inside a sandbox and asked it to pass a hacking test. The agent didn't just solve the test, it found a 0-day, reached the open internet, and broke into Hugging Face looking for the answers. Hugging Face later reconstructed roughly 17,600 attacker actions across a 4.5-day campaign. This wasn't a simulation anymore. A safety evaluation had become a real security incident at another company. I expose the hidden cost of big tech every Monday, Wednesday, and Friday. Subscribe so you don't miss the next one. Before this turns into a killer robot headline, one crucial caveat: OpenAI deliberately reduced the model's cyber refusals and ran the evaluation without the production classifiers that normally block high-risk activity. This was not ordinary ChatGPT behavior. It was a test designed to measure the raw offensive capability underneath those safeguards. The test was called ExploitGym. Its researchers assembled 898 containerized challenges from real-world vulnerabilities in ordinary software, Google's V8 browser engine, and the Linux kernel. The agent starts with proof that a bug exists. Its job is to turn that bug into a working exploit: unauthorized code execution, a stolen flag, proof that the vulnerability can become an attack. OpenAI says the evaluation environment had no direct internet access. It could install software only through an internally hosted package registry proxy called Artifactory. That narrow connection was supposed to be plumbing, not an exit. But the model spent substantial inference compute probing for a way out, discovered a previously unknown flaw in that proxy, and exploited it. From there, they escalated privileges and moved laterally through the research environment until they reached a node with open internet access. The sandbox hadn't vanished. The agent system had found a route around the boundary through the one service the boundary still trusted. Then it searched outward. OpenAI says the models inferred that Hugging Face might host ExploitGym models, datasets, and solutions. Hugging Face believes the entire intrusion was an attempt to obtain those solutions instead of solving the challenges one by one. That is an inference from the behavior, not a transcript of some secret machine motive. But the path points in one direction. First, the agent found a publicly exposed, user-hosted code evaluation harness on third-party infrastructure and repurposed it as a launch pad. The infrastructure provider itself was not compromised, but that external sandbox gave the campaign a root-level staging base for commands, storage, and internet traffic. From that launch pad, it attacked Hugging Face's dataset processing pipeline in two ways. One malicious dataset configuration made a worker read local files, exposing its environment, credentials, and source code. A second abused a template renderer to execute Python inside a production worker pod. Now the agent had a foothold, a map of the pipeline, and a way to send command results back through Hugging Face's own API and attacker-controlled dead-drop datasets. Here's the truth bomb. The 0-day was spectacular, but persistence was the real breakthrough. Hugging Face recovered 6,191 reconnaissance actions, 2,911 remote code execution actions, 6,972 staging and dropper actions. Most attempts went nowhere. The system simply kept testing, rerouting, rebuilding, and returning. On its busiest day, it generated more than 7,600 actions. And when one foothold became vulnerable to deletion, it created a self-respawning fleet across 11 nodes. A skilled human could recognize many of the individual weaknesses: exposed metadata, credentials with too much access, unsafe data processing, trust stretched across clusters. What changed was the coverage. The agent could explore thousands of weak paths, discard failures, and keep the successful fragments. Hugging Face says it went from code execution in one worker pod to cluster admin across multiple internal clusters in under 13 hours. The breach was serious, but the limits matter. Hugging Face says the only customer content accessed was 5 datasets whose names suggested a connection to ExploitGym or CyberGym challenges and solutions. It found no evidence that other customer-facing models, datasets, spaces, or packages were affected. Its operational database was read but not modified, and network logs showed no bulk extraction. but containment still carried a real bill. Hugging Face teams responded around the clock. They rotated credentials, shut down vulnerable paths, rebuilt compromised nodes, and eventually wiped and rebuilt core infrastructure as a precaution. They tightened cloud metadata access, split broad credentials into narrower ones, improved critical alerting, and reported the incident to law enforcement. Then came a second problem. Hugging Face tried to use hosted frontier models to analyze the attack logs. The guardrails blocked parts of the work because real incident response data looks like malicious code. So the defenders stood up an open weight GLM 5.2 model on their own infrastructure to decode payloads and reconstruct the timeline. An OpenAI-driven agent helped create the incident. A locally controlled model helped untangle it. This does not prove that a public chatbot is secretly plotting an escape. It does prove something more immediate. Once a capable agent can write code, invoke tools, touch credentials, and keep working for hours, the evaluation environment becomes part of the attack surface. The test cage is security critical infrastructure. The fix is not one magic alignment prompt. It is defense in depth. No unnecessary internet path, short-lived credentials, blocked metadata access, narrow trust boundaries, rapid behavioral detection, and a stop condition that does not depend on the agent politely respecting scope. Safety has to constrain both the model and the tool the model can reach. So who should certify high-risk AI safety tests before they run? The company building the model, or an independent body with the power to inspect the containment plan? Tell me where you would draw that line. Subscribe if you want the evidence behind big tech's promises and the costs that disappear when the demo ends. Next, watch 10 septillion years Google's quantum chip won't cut your AI power bill. It is another story about a jaw-dropping benchmark and what the benchmark leaves out when it meets the real world. Silicon Valley Thirst Trap. New investigations every Monday, Wednesday, and Friday.